Good day, everyone. My name is Sulesha Tanapal, and my metric number B0325100164 from Group 33 for BITS 1313 Data Communication and Networking. Today, I will explain and I will be presenting of the introduction and later will be the conclusion of our mini project. Our project focused on addressing a complete ICT infrastructure for a medium-sized organization. The network setup organized of a headquarters and two main branches offices which is located in Skudai and Kuli. The main objective of this project are first to design and scalable and efficient network that supports both wire and wireless devices. To improvement variable length subnet masking, which is VSLM, for efficient IP address utilization to ensure smooth communication between all departments and branch offices, and to simulate and the test network using Cisco Packet Tracer. And our report include physical and logical diagrams and IP address schemes and devices configuration, connectivity testing, and recommendations in future. A packet tracer simulation file and a video demonstration were also prepared to validate our design. Now I will pass to my members who will explain the network design more clearly.
Hello, my name is Amelia and I will be presenting the logistic detail for our proposed network solution for BITC 33 CMBHD. Starting with our headquarters in Shah Alam, we have planned a 4-story building layout. On the first floor, we have the technical department with 4 wired PCs. Moving to the second floor, the management department house 6 wired PCs along with 4 wireless PC and 2 wireless notebooks to support mobility. The third floor is dedicated to our server farm, containing 4 wired servers that host our central services. Finally, the fourth floor supports sales and marketing with a fully wireless environment consisting of 5 wireless PC and 5 wireless notebooks. Next, our Kulim branch consists of 2 single-story houses. House A serves as the service department with 4 wired workstations, serves as the service department with 4 wired workstations. House B acts as the staff hostel, where we provided wireless connectivity for 6 notebooks, which is our Group 33's 6th value. Lastly, for our Skudai branch, we utilized a 2-story building. The ground floor is the service department equipped with 6 wired PCs. The first floor is the staff hostel, supporting 10 wireless notebooks for our employees. Each location has been assigned a gateway interface and wireless access points to ensure seamless connectivity across all departments. Now I will pass the presentation to my teammate to explain the addressing scheme.
Nama saya Nursyah Zaizaty binti Muhammad Zuraimi. Nombor metrik saya B0325108117. This diagram shows the overall network topology of a company. The headquarters, Shah Alam with 2 branch office, branch Kulim and branch Skudai. Through a wide area network 1, this design ensures that all department floor and branch can communicate with each other efficiently while sharing centralized services such as servers and internet access. Headquarters Shah Alam at the main network hub of the organization. All critical server, core switch and routing devices are located here, making it the central point for data processing, management and control. Wireless sales and marketing department use wireless access to connect laptop and PC. This setup allows employees to move freely while maintaining network connectivity, which is suitable for dynamic working environments such as sales and marketing activities. Third floor, server room, hosts several important servers including application server and file server. And second floor, management department, connected using wired connection door switch to ensure stable, secure and high-speed communication for management tasks such as reporting, decision making and administrative work. For branch cooling, represent a remote office connected to the headquarters via the WAN. It has its own internal network but relies on the headquarters for centralized service such as DSL and web hosting. For cooling, has House A and House B are connected through switch and access point. Branch cooling router manages communication between the local network. It forward traffic to headquarters and ensure the user in cooling can access server. For branch Skudai, another remote office connected to headquarters via the WAN. And Skudai, ground floor consists of multiple PCs connected through a switch, and the first floor many use wireless connectivity for laptop trust and access point. In conclusion, this network topology demonstrates as well structured enterprise network that integrate headquarters and branch office using a WAN. The design supports both wire and wireless user, centralized service, and efficient inter-branch communication.
My name is Nur Izzati. Today I will demonstrate about addressing scheme. This is our addressing table. The headquarters network use the IP block 172.68.6.64, while the branches network use 10.0.0.0. To efficient use IP address, we apply variable length subnet masking. Each floor and location was assigned a /28 subnet, which provides 14 usable IP address. This is sufficient for the number of wired and wireless devices at each location. A /28 subnet, which provides 14 usable IP address. This is sufficient for the number of wired and wireless devices at each location. Okay, one example of subnet in second floor management. You can see the subnet gateway address. For each subnet, the first usable IP address was assigned as the default gateway on the router. Okay, after assigning the gateway, IP address were located sequentially. Wired PC were assigned the lower IP address, followed by the access point, wireless PC, and wireless laptop. Topological network topology includes the headquarters and two branch office, that is Cooling and Skudai. Each location was assigned a different IP network block based on the project requirements. The DNS and web server IP. All devices were configured to use the DNS server. The internal web hosting server, which hosts www.bonus.com, was assigned the IP address. Lastly, this addressing scheme ensures efficient IP usage, clear network segmentation, and reliable communication between all departments and branches.
So for this section, I'm going to talk about device configuration settings, which is to verify that all devices in each location are properly configured. First, for the wired host, we have configured the PCs with the correct IP addresses, subnet mask, and default gateway according to their allocated locations. This ensures that each wired PCs belong to the correct subnet. Next, for the wireless host, we have configured the laptops and verified that they are connected to the correct SSID through the access point. Each device shows that a valid IP address, subnet mask, and default gateway, confirming successful wireless connectivity. For the gateway interface, we have configured the router LAN interface at each location using the first usable IP address as the default gateway. This allows all hosts in the network to communicate with the other subnet through routing. Finally, For the access point, the SSID configuration confirms that the wireless network name is correctly set for the users by following the location name such as HQ, Kulim, and Skudai. This ensures that the wireless devices are easily discovered and connected. Overall, the network devices at HQ, Kulim, and Skudai are correctly configured, ensuring a stable and well-structured network.
Okay, let's move to the next, which is connectivity test. Connectivity testing was conducted to verify that the proposed network infrastructure was correctly configured and fully operational. So the first one is HQ wired PC to router. The results are the ping request from the HQ wired PC to the default gateway returned successful replies, indicating that the LAN configuration at the headquarters is functioning correctly. Figure number 2, which is HQ wired to wireless. The results: successful ping response confirm that the access point breaches wireless and wired device properly, allowing seamless communication within the headquarters network. Figure number 3, which is HQ PC to Kulim PC. The results: successful ping replies indicate that the routing between the headquarters and the Kulim branch is correctly implemented and that the branch network is reachable. So figure number 4, which is inter-branch, which is Kulim PC to Skudai PC. The result: successful ping replies confirm that the network supports false inter-branch communications and that routing paths are correctly established. Okay, for the final one is appendices, which is web server access test. We will be using www.bonus.com. This test verifies domain name system, which is DNS configuration and external network access. It ensures that host can resolve domain names and access external service through the network. These are the results. The successful loading of the website confirms that DNS is properly configured and that the network has external connectivity.
Alright, so that was the explanation from my group members covering the network design, IP configuration, and implementation designs. Now, we are coming to the final part of the presentation, which is the conclusion. The conclusion I would like to share, which is our project proposed the network design successfully connects 58 devices across the headquarters and the branch offices. The VSLM implementation was done efficiently and achieving 100% utilizing of the allocated IP addresses. All connectivity and routing tests was successful and confirming that network functions as intended and good. Overall, we have successfully achieving all our project objective. A fully functional network was designed and simulated. VSLM was correctly applied. Communication between all devices was verified and the external web service is accessible and across the network. For the future implementations, we recommend implementation VLN enhance inter-department security, adding backup router and links for the redundancy. Applying a firewall between the headquarters and branch offices. Planning for IPv6 migrant and using network monitoring tools such as PRTG or SolarWinds. With that, we have to come to the end of our presentation. Thank you for listening. Thank you.